Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Picture this, an otherwise strong higher paper where students dropped the same 2 marks again and again. It wasn't calculus, it wasn't trigonometric identities, it was a quadratic inequality. Sounds familiar? Stick with me for the next 10 minutes and you'll have a single routine that makes these questions predictable, not panic-inducing.
I always get stuck on whether to draw the parabola or do a sine table. Which one should I learn first? Both are useful. Today we'll learn a routine that uses factorising and a simple sign chart as the main tool, with a quick parabola check if you prefer a picture. We'll use one clear example end to end. Ready? The concept. Step 1. Write the inequality with 0 on one side. Example, solve x squared minus 5x plus 6 greater than 0. That's x squared minus 5x plus 6 greater than 0. Don't panic, that's factorable.
Step 2. Factorise. X squared minus 5x plus 6 factors to x minus 2, x minus 3. So we rewrite the inequality as x minus 2, x minus 3 greater than 0. Write those factors down. Examiners want to see the algebra.
So the brackets give the critical points, right? X equals 2 and x equals 3? Exactly. Those are our critical points. Step 3. Put them on a number line and split the real line into intervals, minus infinity to 2, 2 to 3, and 3 to infinity. Now we test the sign of the product in each interval. That's the sign chart method. Pick a test value in each interval. For minus infinity to 2, choose x equals 0. Substitute into x minus 2, x minus 3. You get minus 2 times minus 3, which is positive, so the product is positive on that interval. For 2 to 3, pick x equals 2.5. 0.5 times minus 0.5 is negative. For 3 to infinity, pick x equals 4. 2 times 1, positive. So the product is positive outside the roots and negative between them. So because the inequality is greater than 0, we take the outside bits, x less than 2 or x greater than 3. Yes, exactly. The solution is x less than 2 or x greater than 3, which in interval notation is minus infinity to 2 union 3 to infinity. Important detail. Because the original sign is a strict greater than, we use open circles or parentheses in the interval notation. Do not include 2 or 3. Write that on your number line. Let that sink in. Why does the sign chart work? Think of each factor as switching sign only at its root. For x less than 2, both x minus 2 and x minus 3 are negative, and a negative times a negative is positive. Between 2 and 3, one factor flips sign, so the product is negative. After 3, both are positive. It's purely arithmetic, no magic. That understanding stops guesswork. And if the quadratic had a negative leading coefficient, like minus x squared plus, what changes? Good question. The sign chart method is identical. Factorise if possible, find critical points, and test each interval. You can also multiply both sides by minus 1 to make the leading coefficient positive, but be careful, multiplying by a negative flips the inequality sign. If you do that, use the flip correctly. Personally, I prefer to keep it in factor form and test intervals. It's less risky in a timed paper. The exam technique. Here's what examiners reward. If this is a 3-mark question, you usually get M1 for writing the inequality as product of factors or an equivalent expression, M1 for identifying the critical points and using a sign chart or test points, and A1 for the correct final answer with correct interval notation or number line notation. So play to those marks. Write the factors, write the critical points, sketch a small sign chart, and then the final answer. What if I can't factorise neatly in the exam? Do I lose the first method mark? Not necessarily. If you can't factorize, rearrange to 0 and show the quadratic formula to find the roots. That also gains M1 for the critical points if done correctly. The key is to show the root to the roots, factors or formula. Even partial work showing the correct roots often picks up method marks. Don't leave the paper blank. Write the setup. Let x minus a times x minus b or use quadratic formula. The examiner sees your method.
Common rubric traps: forgetting to use open circles for strict inequalities, forgetting to test intervals so you choose the middle region incorrectly, and not showing any working. If you write only x less than 2 or x greater than 3 without showing critical points or factors, you risk losing method marks if the examiner can't see how you got there. Write factors x minus 2, x minus 3, critical points x equals 2, 3, testing gives solution x less than 2 or x greater than 3. Short and exam-friendly phrasing.
The quick win, a 10-second sanity check you can use in timed papers. After you pick your final intervals, substitute one easy test value from each interval back into the original expression. If your product sign matches the inequality sign, great. If not, you've miscopied a sign or misordered your roots. Quick mnemonic: factor, roots, sign, test, or FRST. Say it once when you start the question, and again right before you write the final answer.
Frast, easy to remember. So test 0 for the left interval in our example and check it gives positive, yes? Exactly. For x equals 0, x squared minus 5x plus 6 equals 6, which is greater than 0. That confirms the left interval belongs in the solution. This test catches about 90% of small errors and takes 10 seconds. Don't skip the check. That's your quick win for today. If this helped, you can grab printable sign chart sheets and worked questions at jcacademyonline.co.uk. The link's in the show notes. Outro. One-sentence recap. Use the routine factor, find critical points, sign chart or test points, then write interval notation, and you'll stop losing avoidable marks on quadratic inequalities. If this episode helped, share it with a friend who's revising. Visit jcacademyonline.co.uk for more worked solutions and printable practice. Bonus practice. Quick walkthrough of a slightly harder example. Solve 2x squared minus 5x minus 3 less than or equal to 0. Rearranged already, factorize to 2x plus 1 times x minus 3 less than or equal to 0. Critical points are x equals minus 1/2 and x equals 3. Intervals minus infinity minus 1/2, minus 1/2 3, 3 infinity. Test a value in each. Pick x equals minus 1 gives minus 1 times minus 4 positive. X equals 0 gives 1 times minus 3 negative. X equals 4 gives 9 times 1 positive. The product is negative between minus 1/2 and 3. Because the inequality is less than or equal to, we include the endpoints. Solution is minus 1/2, 3. Write closed dots on the number line to show inclusion.
Nice. That shows the same routine works even when the quadratic isn't monic.
Resources and sign-off. You'll find printable sign chart sheets, worked solutions to both examples we used, and a one-page checklist for parents and teachers at jcacademyonline.co.uk. For parents, have your student read the question twice, factor or show the quadratic formula, write the critical points, and then test one value in each interval. That's how the examiner sees the method and awards the marks. Stay curious.